If A contains P elements, B contains Q element, the number of elements in the Cartesian product is P into Q. So with the elements of B union C, you should pair the elements of A. So before finding A cross A, let me find first what is A cross A. So when you are multiplying the same set, that means they have same number of elements. Hello everyone, a warm welcome to one and all. This is Shruti, lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So today I'll be introducing a new chapter, Relations and Function. So let us see what are the topics we are going to discuss it on today's session. So before going to relations or a function, we have to know the concept called Cartesian product. So what do you mean by this Cartesian product? We'll see in today's session. Now, Cartesian product is nothing but if you have any two sets, for example, sets P and Q, then the Cartesian product of the set P and Q is given by P cross Q. And how the elements of P cross Q will be, it is in an ordered pair. That is, it will be in the form of P comma Q, where all the P, that is the first element in the ordered pair or from the set P, and the Q, that is second element of the ordered pair, are from the second set Q. So that is what the Cartesian product says. So if you have any two sets and the two sets must be non-empty sets. So any non-empty sets P and Q, then P cross Q is defined as the collection of all the ordered pairs in the form of P comma Q, where P belongs to set P and Q belongs to set Q. And suppose if P or Q are null set, that is if they are empty, then what do you mean by P cross Q? If you don't have any elements in any one of the set, either from P or Q, then you don't have any elements to pair and write an ordered pair. So therefore, the P cross Q will be empty. Here I have taken an example. If set A is red and blue and set B contains the element BCS. As I said, P cross Q means write it in an ordered pair so that all the first element is in the first set and the second element in the ordered pair is in the second set. So therefore, if I pair this, how I can pair red comma B? Write it in an ordered pair with the common brackets, and red C. So red B, red C, red S. Then come to the second pair, blue B, blue C, blue S. So this is how we pair the elements in any two set. Thus, pairing of these elements from the two set is nothing but Cartesian product. So therefore, hence A cross B is written like this. You can see all the first elements here belongs to the first set A. Red and blue belongs to the first set A. They are the elements of A, and the second elements BCS belongs to the second set B. That is what the definition of Cartesian product say. So it is the product or written in an ordered pair where all the first element belongs to the first set and second element belongs to the second set. Next, we have some important points to note down about Cartesian product of sets. So here the first point goes, two ordered pairs are equal if and only if the corresponding first element is equal to the first and the second element is equal to the second element. Suppose I write two ordered pairs like A comma B and C comma D. When we say that these two ordered pairs are equal, so we say they are equal if the first element is equal to the first element and the second element is equal to the second element. So according to this, if A is equal to C, B is equal to D, then we say ordered pair A comma C is equal to the ordered pair C comma D. Next, if there are P elements in set A and Q elements in set B, then how many number of elements does A cross B contains, that is P into Q elements. You can see in our previous example, set A has 2 elements, that is red and blue. Set B has 3 elements. So therefore, A cross B has 2 into 3, that is 6 elements. You can count here 1, 2, 3, 4, 5, 6. So therefore, what we can say is, if A contains P elements, B contains Q element, the number of elements in the Cartesian product is P into Q. That is the product of number of elements in each set. Next, if A and B are non-empty set and if any one of the set is infinite. So if you have infinite number of elements, we have infinite elements to pair. Therefore, A cross B will be infinite. Next, we have, so here we have one more, A cross A cross A. That is, we are pairing the same set 3 times. Then it is called as ordered triplet. Ordered triplet. So if you have an elements A cross A, then you have 3 elements in an ordered pair. So all the elements belongs to the same set. Since you are pairing the same set, the elements which are inside the ordered pair will belong to the same set. That is, all first, second and third element will belong to the same set. Those type of Cartesian products are called as ordered triplet. So using this concept, now we are going to solve some problems. So here we have a question. If x plus 1, y minus 2 is equal to 3, 1, find the values of x and y. When we say two ordered pairs are equal, when the ordered pairs are equal, their first element is equal to the first element and the second element is equal to the second element. So using that concept, we can find the values of x and y. Let me equate the first element and the second element. So what happens now? So here, according to the equality of ordered pair, I can write x plus 1 is equal to 3 and y minus 2 is equal to 1. So if you shift one side, you will get it as 3 minus 1. So therefore, the value of x here is 2. And if you shift minus to that side, it will become plus 2. So therefore, your value of y is 3. So therefore, the value of x is 2 and the value of y is 3. So these type of question will carry 1 marks. Next, we have same kind of question with different values. We have x by 3 plus 1, y minus 2 by 3 is equal to 5 by 3, 1 by 3. So again, using the concept of equality of ordered pair, let me equate the first element and the second elements. So what happens? X by 3 plus 1 is equal to 5 by 3. Similarly, y minus 2 by 3 is equal to 1 by 3. So what I will do here, I'll multiply 3 to the whole equation. When I multiply 3 to the whole equation, what happens here? X by 3 into 3 plus 1 into 3 is equal to 5 by 3 into 3. So 3 get cancels here. So here x plus 3 is equal to 5. So x is equal to 5 minus 3. X is equal to 2 we get. Next, we have y minus 2 by 3 is equal to 1 by 3. Let me shift this one. So it will become 1 by 3 plus 2 by 3. When you have the same denominator, you can add the numerator. So this becomes 3 by 3. It get cancels. Y is equal to 1. So this is how we will get. You can use the concept of multiplying 3 here also. You will get the same answer. Next, here we come to write the set of ordered pairs. We have a set P is equal to ABC and Q is equal to R. Form the sets P cross Q and Q cross P. Are these two sets on products or equal? So let me write first what is P cross Q. P cross Q, pairing all the elements from P and Q. So how I can pair? First elements of P, then elements of Q. So I have only one element here. So this will become A, R, next B, R and C, R. So that's all, because we have only, here we have 3 elements, here we have 1 element, 3 into 1. So P cross Q has 3 elements. Next we'll see Q cross P. Q cross P means first you take elements from Q, then pair with R. We have only one elements from Q, pair with P. So it becomes R comma A, R comma B, R comma C. What about the number of elements? Here also it is same because 1 into 3 is same. So both contains 3 elements here and 3 elements here. And the question here is, are these two products are equal? I'll say no. Why? Because you can see the ordered pair here. Here A comma R we have, but here we have R comma A. They are not equal. Similarly, B comma R cannot be equal to R comma B, and C comma R cannot be equal to R comma C. So we can clearly say the ordered pairs are not equal. So therefore the product is also not equal. Even though they have same number of elements, their ordered pairs are different. So what we can conclude? We can conclude P cross Q is not equal to Q cross P. That is, we can say the Cartesian product is not commutative. Next, here we have a question of, let A is equal to 1, 2, 3, B is equal to 3, 4 and C is equal to 4, 5, 6. Find A cross B intersection C, A cross B intersection A cross C, A cross B union C, A cross B union A cross C. So what I will do here? So let me take the first one. So before making Cartesian product, let me write what is B intersection C. So first write what is B intersection C. What is B intersection C? What are the common elements here? So intersection means writing only the common elements. So what are the common elements we have here? Only 4. Now I will pair with A and B intersection C. So A cross B intersection means, what is my A? 1, 2, 3 cross 4. Now write it. What happens? In an ordered pairs, 1, 4, 2, 4, 3, 4. So this is how we will pair. Next we take A cross B intersection A cross C. So before that, first write A cross B, A cross C, then take the intersection. So second question, let me write A cross B first. So what are the elements in A? 1, 2, 3. B is 3, 4. Just pair them. So that is 1, 2, 3 cross 3, 4. If I pair them, I'll get first pair with 1. So 1, 3, 1, 4. Next pair with 2, 2, 3, 2, 4. Next pair with 3, 3, 3, 3, 4. Next we have A cross C. So what is my A? 1, 2, 3 cross C is 4, 5, 6. So pair the elements individually. First let me take with 1, 1, 4, 1, 5, 1, 6. Next 2, 2, 4, 2, 5, 2, 6. Next with 3, so 3, 4, 3, 5, 3, 6. So what is the given question? A cross B intersection A cross C. That means you have to find the pair of elements which are common in both the sets. So what are the common elements in both the sets? So we have 1, 4 in common. Next we have 2, 4. Next we have 3, 4. So therefore the elements are 1, 4, 2, 4, 3, 4. So from the first two cases, here you can see A cross B intersection C is same as A cross B intersection A cross C. So this can be stated as one law. So this can be stated as a statement like this, that is A cross B intersection key can be written as A cross B intersection A cross C. Because you can see A cross B intersection C is also 1, 4, 2, 4, 3, 4, and this is the intersection of their cross product is also 1, 4, 2, 4, 3, 4. We can also conclude the statement as above. So in the same way, you can also find A cross B union C, which is also equal to A cross B union A cross C. So I have concluded the statement. Now let me look at the third and fourth. So let me verify B union C first. What is B union C? So B union C is 3, 4, 5, 6. If you pair with A cross B union C. So with the elements of B union C, you should pair the elements of A. So what happens there? So pair the elements from A to B, that is what you will get 1. So 1, 3, 2, 3, 3, 3. Next you have 1, 4, 1, 4, 2, 4, 3, 4. Next you have 1, 5, 2, 5, 3, 5. Next you have 1, 6, 2, 6, 3, 6. So you can also check by counting the number of elements. Here we have 3 elements. Here we have 4 elements. So 3 4s are 12 elements it should contain. Next we will verify A cross B and A cross C. So A cross B. So let me write A cross B. So what is A cross B? Pair the elements of A with B. So 1, 3, 2, 3, 3, 3. Next 1, 4, 2, 4, 3, 4. Next, we'll pair with A cross C. So 1, 4, 2, 4, 3, 4. 1, 5, 2, 5, 3, 5. 1, 6, 2, 6, 3, 6. Next, take the union of these two sets. So A cross B union A cross C. So when you take the union, that means you are going to write all the elements here. So union of these two sets. So 1, 3, 2, 3, 3, 3. 1, 4, 2, 4, 3, 4. Next 1, 5, 2, 5, 3, 5. Next 1, 6, 2, 6, 3, 6. So you can clearly see here A cross B union C is equal to A cross B union A cross C. So this can also be concluded as one more statement. So these two are equal. Again, you can count the number of elements here also. So A cross B contains 6 elements. A cross C contains 9 elements, but you have a common elements which you can write only once. That is 1, 4, 2, 4 and 3, 4. So therefore, you can see the union of these two sets, which will give you the 12 elements, which is same as A cross B union C. Next question, state whether each of the following statements are true or false. If the statement is false, rewrite the given statement correctly. So what is my first statement? If P is equal to Mn, Q is equal to Nm, then P cross Q is M, N and N, M. Let me verify this. So what is my P cross Q? So pair the elements with Q. First element is M. So M, N, M, M. Next with second element N, 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 M. That's all. So 2 elements here, 2 elements here. So 2 2s are 4 elements here. So do you find the same thing here? No. So m comma m and n comma n are not present in P cross Q. So therefore the given statement is false and we have written them correctly now. Next question. If A and B are non-empty set, then A cross B is a non-empty set of ordered pairs x comma y, where x belongs to A and y belongs to B. Correct? This is the definition of Cartesian product. So what does our Cartesian product says? If A cross B, it is the set of all ordered pairs x comma y, where x, that means first, belongs to the first set and the second element y belongs to the second set. So therefore the given statement is true. Next question. If A is equal to 1 2, B is equal to 3 4, then A cross B intersection empty set is empty. What is the intersection of any set with empty set? Since empty set contains no element, their intersection is empty. So if their intersection is empty, then A cross empty is also empty. Because we have studied, whenever you are pairing with an empty set, what is the definition of Cartesian product? A and B are non-empty set. When they are empty, there is nothing to pair. So you cannot find the Cartesian product. So therefore, the Cartesian product of a set with an empty set is again empty. So therefore, the given statement is true here. Next, we have a question. If R is the set of all real numbers, what are the Cartesian product of R cross R and R cross R cross R represent? So if I take any element A comma B belongs to R. So since the given, they are all set of all real number. So if R cross R means they are written in the form of A comma B as a Cartesian product which contains an ordered pair and both belongs to the same set. This set is actually representing the Cartesian system in 2 coordinates. Two coordinates. So that is your x and y axis. So R cross R represents the Cartesian coordinate system in your x and y axis. Next, suppose if it is R cross R cross R. So this is a ordered triplet. So that is all A, B, C, all the 3 terms will be a real number, and this is represents 3-dimensional Cartesian system. So that is x, y, z axis. Next, we have a question. A is equal to -1 comma 1. Find A cross A cross A. So before finding A cross A cross A, let me find first what is A cross A. So A cross A means, so pairing -1 comma 1 cross -1 comma 1. So pair it now. A cross A is equal to, when you pair it, it is -1 comma -1, -1 comma 1. Next, 1 comma -1, 1 comma 1. So 2 elements here, 2 elements here, 2 2s are 4 elements here. Next, we have A cross A. Now already we got A cross A. So what are those? -1, -1, -1, 1, 1 -1, 1 comma 1. Cross with again the same element -1 comma 1. Now pair it. We have -1 comma -1 comma -1. Next we have -1 comma 1 comma -1. Next we have 1 comma -1 comma -1. Next we have 1 comma 1 comma -1. Next, pair all these with the second element, that is -1, -1, 1, -1, 1, 1, 1, -1, 1, 1, 1, 1. How many elements? 8 elements. 2 into 2 into 2. 2 to the 4, 4 to the 8 elements you are having in your triplet. So you can see all the elements A, B, C according to the definition 1 minus 1 minus 1 all belongs to the same set. But number of elements in their product is different. Now here is a question. If A cross B is equal to A, X, A, Y, B, X, B, Y, find A and B. What is the definition of Cartesian product? If A cross B is the Cartesian product, then it is written in the form of A, B, where all the first element belongs to the first set and the second element belongs to the second set. So using this definition, you can see here A cross B is given by A, X, A, Y, B, X, B, Y. So according to this definition, all the first elements should be in the first set. So what are the first elements we have here? Here we have A and B. So therefore A is equal to B. What are the second elements? That is X and Y. So we have found A and B. Next, A is equal to 1, 2, B is equal to 3, 4. Write A cross B. How many subsets will A cross B have? Okay, so if you have n elements in a set, then number of subsets is equal to 2 power n. This we have learned in the chapter sets. So when you have two elements, if A has two elements, so let me take if A has two elements, then number of subsets will be 2 square, which is equal to 4. So what are those subsets? One is empty, another one is singleton set, another one is set A itself, that is A, B. So we can form 4 subsets. So based on number of elements, we can have how many subsets we can form. So the same concept here I am going to use now. Now first let me find out what is A cross B. So 1, 2, 3, 4. First pair with 1. So it is 1, 3, 1, 4. Next pair with 2, 2, 3, 2, 4. So how many elements you have? So number of elements in A cross B is 4. So therefore, number of subsets of A cross B will be 2 power 4, that is equal to 16 subsets. Here you can form 16 subsets of A cross B. This gives rise to the definition of relation, which we will study in the next session. So number of subsets of any set is given by 2 power n. Since A cross B has 4 elements, the number of subsets is 2 power 4, which is equal to 16. Next we have the Cartesian product of A cross A has 9 elements, among which are found -1, 0, 0, 1. Find the set A and the remaining elements of A cross A. So here we are multiplying the same set. So when you are multiplying the same set, that means they have same number of elements. What is given? A cross A has 9 elements. So 9 elements. That means here A contains 3 elements. So 3 3s is equal to 9. So therefore, what does it implies? Number of elements in A. So number of elements in A is 3. And they have given these two as an ordered pair. So in the set of A cross A, you have 2 elements -1, 0. So by seeing this only, we can see 3 different elements it contains. One is -1, 0 and another one is 1. So therefore, what are the set A? The elements are -1, 0, 1. So since A contains 3, A cross A must have 9 elements, and the elements of A are -1, 0 and 1. Also, they have asked you to find the remaining elements of A cross A. So just pair with A cross A, we have -1, 0, 1. So now pair again -1, 0, 1 with minus 1, 0, 1. So when you pair it, so it is minus 1 comma minus 1, minus 1 comma 0, minus 1 comma 1. Next we will pair with 0. 0 comma minus 1, 0 comma 0, 0 comma 1. Next we will pair with 1. So 1 comma minus 1, 1 comma 0, 1 comma 1. So you can see you have 9 elements here. So total 9 elements. A has 3 elements. So that's all. This is all about how we write a Cartesian product of any two sets, which is very important concept before going to relations and function. Also note that the questions of Cartesian product may carry 1 marks in your examination. So that is finding the value of x. Also 2 marks question may be like finding A cross B intersection C or A cross B union C, or finding the sets or the elements of sets A and B whenever the Cartesian product is given. So we'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.